Hello everyone, I'm Barbara D'Ambrosia and this video is about dividing numbers by powers of 10. That is, numbers like 10, 100, 1000, 0.1, 0.01, etc. I'm not recording my camera for this video, but I thought I should show you my face at least once. So here I am, sipping from one of my mini math mugs. We'll start with the number 13.2 and look at what happens when we divide this number by 10. You may have been taught that when we divide a number by 10, the decimal point shifts one position to the left. But is that really what happens? Here we see the original number, 13.2, and the result after we divide by 10, which is 1.32. It certainly looks like the decimal point in the second number is one position to the left of the decimal point in the first number. But let's step back for a moment and review what we know about base 10 numbers. Recall that moving to the left from the decimal point, we have the ones position, the tens position, the hundreds position, and so on. And moving to the right from the decimal point, we have the tenths position, the hundredths position, the thousandths position, and so on. The number 13.2 has 1 10, 3 ones, and 2 tenths. And 13.2 divided by 10 is 1.32, which has 1 1, 3 tenths, and 2 hundredths. In this view, notice that the decimal point did not move when we did the multiplication. In both numbers, the decimal point is between the ones position and the tenths position. This is the case for any base 10 number. The decimal point is always between the ones position and the tenths position. Although the decimal point does not move when we divide by 10, the digits in 13.2 each move one position to the right. The 1 in the tens position moves to the ones position. The 3 in the ones position moves to the tenths position. And the 2 in the tenths position moves to the hundredths position. In this next example, we divide 6.84 by 100. Notice that 100 equals 10 times 10. So dividing by 100 is equivalent to dividing by 10 and then dividing the result by 10 again. If that seems counterintuitive, consider this. One way to cut a cake into 100 pieces is to first cut it into 10 pieces and then cut each of those pieces into 10 pieces. Dividing the whole by 100 is equivalent to dividing by 10 twice. We'll use this idea when dividing 6.84 by 100. Each time we divide by 10, we shift the digits of 6.84 one position to the right. So when we divide by 100, we shift each digit of 6.84 two positions to the right. We place a 0 in the empty tenths position and also in the empty ones position. Thus, 6.84 divided by 100 equals 0.0684. Now let's look at 2,490,000 divided by 1,000. Since 1,000 equals 10 times 10 times 10, dividing by 1,000 is equivalent to dividing by 10 3 times. So when we divide 2,490,000 by 1,000, we shift each digit in 2,490,000 three positions to the right. Since there are no non-zero digits to the right of the decimal point, we can remove the zeros from the thousandths, hundredths, and tenths places. So 2,490,000 divided by 1,000 equals 2,490. In general, when we divide a number by 10 to the nth power, we shift each digit in the original number n positions to the right. So for example, when we divide 132.607 by 10 to the 5th, we shift each of the digits 1, 3, 2, 6, 0, and 7 5 positions to the right. Thus, 132.607 divided by 10 to the 5th equals 0.00132607. Before I wrap up this video, I want to talk about what happens when we divide by a power of 10 that is less than 1. For example, suppose that we want to divide 0.792 by 0.01. Notice that 0.01 is 100th, which is 10 to the negative 2 power. So we shift the digits of 0.792 negative 2 positions to the right. The negative indicates an opposite or backwards direction, so shifting negative 2 positions to the right is equivalent to shifting positive 2 positions to the left. And so 0.792 divided by 0.01 equals 79.2. Thank you for watching this video. I hope that you found it helpful.